All right, if you guys are watching this on a replay, so not live, it's going to be a couple minutes. Feel free to fast forward. I need to get the link sent out and everything set up so that people can watch it live. Fast forward to a couple minutes, let's say probably 5 minutes-ish. Let's ready to go. Okay, so link is sent out. So for you guys who are on, welcome. We're going to get started in about 5 minutes. We'll give everybody another couple minutes to get on. And for those of you that are watching this on the replay, again, feel free to fast forward. We're going to start in about 5 minutes. If you want to interact with me at any time, you guys can always send me questions on Remind, or you can chat in the YouTube box as long as you are logged into your YouTube account. So you don't need to create an account. Just if you have one, you can chat on there. But again, we're going to get started right at 7, so I'll give everybody about 5 more minutes, and we'll go from there. If you have questions ahead of time that you know you're going to ask, you can send those too. Ooh, look at everybody on. Hi, guys. Again, we're going to get started at 7, so go grab a snack, throw the game on, catch a couple more minutes if you need to. We'll get started in about 4 minutes. Even grab your review packet, because we will kind of do a bunch of questions from that and then a bunch of questions that are not from that. If you're just logging on, welcome. We're going to get started in about 3 minutes. So you guys can send me questions at any time, either through the chat feature on YouTube, which is right on your screen, or you can just send me a remind. Sometimes that's easier for people. We will get started right at 7. If you're watching this later on a replay, just fast forward through to when we start, which should be about 3 minutes from now. And if you guys want to grab your review sheet, I'm going to hit some of the major questions on there. I'll hit some. A lot of them will be from that. Just watching my fantasy team lose, which is terrible. I hope that your fantasy team is doing better than mine. Although it's not fair, because the person that I'm playing got a lot of points. All right, guys, 2 more minutes and then we'll get started. Again, if you have questions, send them at any time. You can send them on Remind or via the chat on YouTube. You just need to be logged in to your YouTube account to do that. And we'll get started in 2 minutes. This is riveting stuff while we wait. I know. It's very exciting. All right, about 1 more minute and then we'll get started. Okay, so let me give you guys kind of a rundown of how this works if you've never done a live stream review with me before. So first of all, you are on a slight delay from me. So if you have questions, send them along. I might not answer them immediately, but it's probably because I'm like a little bit ahead of where you are. So when I see them, I'll answer them. You can send me questions either through the chat link or the chat box on YouTube, or just send them to me on Remind. Both are good. I have my phone right here. I will get your reminds immediately. So send those away. I'm going to go through a variety of topics, but if you have specific questions, let me know. I'm going to kind of hit the major things, and I'm happy to answer questions at any time. At the end, I will hang out for a little bit so that if you have extra questions, we can go over them. But this is for you, so utilize it however you need to. If you're watching while you're replaying this, a great strategy is to like pause the video, try it yourself, and then go from there. But if you're watching it with me, then great, you're getting review a couple days ahead, and that just gives you more time to review in the long run. So test is Tuesday, and it will be the whole block. You'll have the whole time. It will cover all of Unit 1, and the best thing that you guys can do is remember that you have learning targets for this unit. So if we look at your unit organizer, your stamp sheet, right, you have these learning targets on the back of the stamp sheet. So your prereq skills are these first part. These here are your prerequisite skills. And then from there, we have the Unit 1 learning targets. So what I would say is, as you're studying, go through these and say, I can determine when a relation is a function. Check. I can determine the domain and range. Check, right? And you can use these as a study guide to actually go through and study with. So it's a really good way to make sure you actually can handle everything that can come at you. All right, so we're going to go through some questions that were on the review sheet, some that weren't. I've sort of hit the major topics here, and if there's stuff you have questions on, again, send them along at any time. So starting with this first topic, and notice that I organized your review sheets into these same sort of learning topics. So when you go through, you can say, oh, yep, I can do that, and check it off. A really, really, really good way to make sure you're handling it. So the first thing we're talking about is function notation. So notice that we've got 3 different functions here. One is named G, one is named H, one is named K. That letter is going to be how I identify which function I use, right? So if I'm looking at this, G of 5, this tells me to look at the function G and plug in 5. So when I do that, remember that we said it's always important to use parentheses when you sub in, because that's going to make sure that you don't have an order of operations error, especially when you're plugging into your calculator. So G of 5, anywhere there's an X, I'm instead going to put in a 5. And from there, just follow your order of operations. This would be negative 15 plus 1, which is negative 14. So that basic idea, subbing in, making sure you're using parentheses. Here's where it gets a little bit more interesting. Let's say I'm finding H of negative 2. So notice I'm finding it this function. And this is where your parentheses really matter, because if you put negative 2 squared with parentheses into your calculator, it's going to split out a 4, right? And so this would give you 11. If you do negative 2 without parentheses in your calculator, what your calculator is going to think is to take 2 and square it and then make your answer negative. So you will actually wind up with a different answer. This will come out to be negative 4 plus 7, which is 3, and that's not what we want. So having that negative 2 in parentheses is really important because we know that a negative times a negative should be a positive, right? Okay, now don't let fractions scare you. Let's say I have this, h of 2/5. What that's saying is start with the function h, which again is this, and plug in 2/5. So it's going to be 2/5 squared plus 7. You have calculators. You can plug that in, right? You can put it in parentheses 2/5, square it, and then add 7. So don't let the fact that there's a fraction there scare you. All it is substitution. Again, send questions at any time as you have them. All right, the next one is asking us a little bit more about function notation. So use the graph it right to answer the following questions. And I'm not going to do all of these, but I want to talk about the major difference between questions like A and B and questions like C and D. So this function is f. I can see that from the labeling there. And again, if we had more than one function, you want to make sure you're using the right one. But this is f. So if this says f of negative 4, this right here is my x value, right? So I'm going to look at when x is negative 4, what is y, right? I'm thinking about that as a coordinate point. So looking at my graph here, and when x is negative 4, 1, 2, 3, 4, that's your point that's on f of x, right? And so the y value there is 2. So f of negative 4 should be 2. Again, it's saying when your input is negative 4, what's your output, right? Now, if we go the other way, let's say we look at one like letter D, this says that f of x equals 4. So my x is my unknown here. So it's saying what is x when y is 4, right? So looking at my graph, I'm going to say, okay, where is my y value 4? So looking at the graph here, I'm going to erase that. Y is 4, 1, 2, 3, 4 right here. So I'm actually going to draw a line across there, and you don't have to do that. You could just eyeball it, but I'm going to draw a line across. I'm going to look at where that hits exactly, and it looks to be right there. The x value there is negative 2. So what I can see here is that my x value when y is 4 would be negative 2. And so that is my output there, or my input actually. Now, another thing with function notation, and this was not on your review sheet, so I included this one separately, but we did a warm-up like this. And so it said selected values for f and g are shown in this table. A solution to the equation f of x equals g of x is what? So here's what I'm looking for. I'm looking for where f of x equals g of x, and it needs to happen at the same x value, right? We're looking for what x value has the same output. So basically, we're looking for these x values to match and these f of x and g of x values to match, right? We're looking for there to be the same coordinate point. So let's look at this. If I look at negative 3.12, that is not even an option on g of x. So because that's not an option, I can eliminate that. Now, if I look at 0, 0 is an option on g, but those do not have the same y value, right? So I can eliminate that, not an option. Then I can say, okay, 1.23, not an option on g, so it can't be that. 8.52, that's also an option on g. And notice, not only are my x values the same, but my y values are the same. So that would be the place where these are equal. And so 8.52 is my solution. That's the location where f and g are the same. So we should be able to handle functions in expressions, in equations, in graphs, or from tables. Okay, let's talk about determine is a function. And remember, send questions as you have them. So determine if something is a function. I want you guys to be thinking about going to the movies, right? Would this be a situation that was possible if you were going to the movies? So in this first one, could person 1 go to 2 different movies at the same time? Not possible, right? So this is a no. For the second one, could person 3 go to movie theater 2 and then person 5 and 7 go to movie theater 4? Sure. 5 and 7 are going to a movie together. 3 wanted to do his own thing. That's fine. So that is a yes, right? So think about going to the movies. If it was a graph, I would think about the vertical line test. We don't have that here, so I'm thinking about the movies. Okay, now something I'm going to add on B here is an arrow to signal that that keeps going on forever. Domain and range, and I want to be able to do this algebraically and graphically. I will tell you guys, a couple other classes have taken an Algebra 2 test already, and you will have a different test, but all of the other Algebra 2 teachers so far have said this topic was the one their students struggled the most on. So definitely something I would make sure you look at because this is an Algebra 1 review topic. So remember, domain are your set of all x values, range are your set of all y values. So for domain, I'm going to look from left to right on my screen, and I'm going to think, okay, what's my lowest, what's my highest, and then are these things included? So I going. The first time I hit an x value is right here, right? And so that would be -2 on the x's. This is my domain. Notice that we have an open circle there, so that's going to be a parentheses, comma. Now we're going to keep going, and I see that the function's defined everywhere, right? There's still points everywhere until we get to right there. So right there is where my last x value is. That point is 1, 2, 3, 4. And notice that's a closed circle, so that should be a bracket. All right, now for the range of this one, again, we are looking now at the y values. So now we're going bottom to top. And it doesn't necessarily need to be the same points that we look at, right? Here we looked at this point and this point for domain, but if I look at my bottom and my top points, those won't be the same. This is the lowest point I see. This is the highest point I see. So let's think about what the y values are there. The lowest y value I see is -4, and that's a closed circle, so I'm going to bracket that in. And the highest y value that I see is right here. That's at +3, and it's again a closed circle, so I'll bracket that in. Now let's look at one more of these and make sure we know what to do if that arrow's there and it goes on. So same idea, domain, we're going left to right. My lowest x value that I see is -4, and there's a closed circle. And I see that this keeps going forever, right? So this arrow means that my function keeps going to the right. It doesn't stop. And so this is going to keep going towards infinity. Now, infinity is not a number. We can't have infinity slices of pizza. Infinity is not something that we can count, right? Infinity is not a number. And so this is a concept. It's going to be in parentheses. The range, same idea. We're going to go bottom to top. So going here to here. So there is a lowest value, right? The lowest y value I see is right here. That's when y is 0. And again, it's closed, so I can bracket that in. And then notice that this will keep going up forever. And so this is going to go towards infinity. Again, infinity is not a number. We can't ever reach it. So that's going to be a parentheses. All right, let's look at finding this from an equation, right? Doing it algebraically. So there's 2 scenarios you need to worry about. First scenario, if there is a radical, remember that we cannot take the square root of a negative number over the real numbers, right? That's not something we can do. So if I'm taking the square root of, let's call this a, then we know that a can't be negative, right? Which means a would need to be positive or equal to 0. So whatever's under there, we can't take the square root of a negative over the real numbers. So if I have a radical, I need to remember that what's under there needs to be greater than or equal to 0. If we have a fraction, the issue lies not with a negative anymore. You cannot divide by 0, right? So I can't have a over 0. A over 0 is undefined. And so what we know is that the denominator cannot equal 0, right? So if you have the numerator over the denominator, we know the denominator can't be 0. So knowing these 2 things, that's how I'm going to approach all of these algebraic ones. And I'm actually going to do a bunch of these because this is a topic that people had some questions about. So, and again, continue to send me questions as you have them, okay? Remind, YouTube chat, whatever. So first one, I see no radicals, which is great. I can ignore that. I do see a fraction. And remember, with a fraction, the denominator cannot be 0, right? So I can't have 1 over 0, so I know that x cannot equal 0. Now, think about this. If I ask you, what do you want for your birthday? And you say, not a rubber band, you did not tell me what you want, right? You said what you didn't want. So here, I told you what the domain was not. It's not 0, but I didn't tell you what the domain was. So your domain is actually going to be all real numbers, so negative infinity to positive infinity, except 0. Now, there's other ways you could write that. You could say all real numbers except x can't equal 0, right? Or you could say from negative infinity to 0, union 0 to infinity. So just leaving out 0, right? All of those are correct. None are more correct than the other, and it's really up to you how you write them. Okay, let's look at C. So for C, and I know I'm going a little out of order. That's okay. No radicals, good. Fractions, okay, we can deal with that. So the fraction, remember what we said was the denominator cannot equal 0. So I'm going to take my denominator and I'm going to restrict it. I'm going to say x cannot, or 3x plus 9 can't be 0. And this is not as simple as the one before. We actually need to solve for x here. So 3x cannot be negative 9. X cannot be negative 3. And again, same situation. That's what you don't want the domain to be. So the actual domain would be all real numbers except negative 3. And let's look at this last one. And sometimes people get confused about ones like E because they're like, ooh, wait, but there's an x in the numerator. It doesn't matter. All we care about is that our denominator cannot be 0 because we can't divide by 0. So that would tell me that x cannot equal 2. So my domain would be all real numbers except 2. Okay? It's always the same thing with fractions. Let's look at a radical. So remember, with radicals, we don't have denominators to worry about. But what we're worried about here is that the part under here can't be negative, right? So I'm going to take the part under the radical, and I'm going to make that greater than or equal to 0, because 0 is fine, positive is fine, which tells me that x is greater than or equal to 3. Now, this is the domain, right? It's not telling you what it can't be. So that is an answer. But you could also say, okay, let's think about a number line. There's 3. X could equal 3, or it could be greater than 3. So the other way you could think about writing this is 3 with a bracket, and then every number bigger than 3. All right, let's do another one of these. So on this one, again, no denominator, not worried about that. But here, I know that that part under the radical needs to be greater than or equal to 0. So I'm going to add 2x to the other side, divide both sides by 2. And so here I have that could be my domain. Or we could say, all right, so here's 4. X could equal that. Or x is less than 4. So that would actually be negative infinity to 4 with a bracket. So that's something I would make sure that you look at. Radical versus the denominator, but either way, those are ways to find your domain. Okay, average rate of change, our next big topic. So average rate of change, immediately into your mind should pop slope, right? And we should know that our slope formula is change in y over change in x, or y2 minus y1 over x2 minus x1. Remember that y goes to the sky. So if you're forgetting where the y's go, y goes to the sky. It goes on the top. All right, so let's look at one of these. So number 6, and this one is from your review sheet, says, given the following functions, g, f, and h, list the function ordered greatest to least by average rate of change over the interval from 0 to 3. So remember, when you're finding slope, you want points. And what it's telling you here is that these are your x values, right? So those are my x values. 2 of these are a little bit more straightforward. 1 is a little bit less. So let's start with the more straightforward ones. I want to go from 0 to 3. Those are my x values. So those are the 2 coordinates I'm going to use. So my average rate of change here for f is 7 minus 1 over 3 minus 0. That's 6 over 3, which is 2. So the average rate of change for F is 2. Now, G we're going to come back to. Let's look at H. So for H, we're going again from 0 to 3, which is not there. Mrs. G, it's here. And I'm looking for the slope of the line that connects those, right? That's called a secant line. So this point is 0, 2. I'm going to write this over here. And this point is 3, 9. Now, you could count here. You could go up 7 over 3. And you could also do 9 minus 2 over 3 minus 0. And that's 7 over 3. So those are my two slopes there. Now, the thing about G is that we don't have the values, right? We know that the X values we want are 0 and 3. And to get Y values, that's where you need to think, ooh, I have X, I want Y. I'm going to plug into this equation. So G of 0 will be 0 squared minus 2 times 0. So that's just 0. And G of 3 squared minus 2 times 3. That's 9 minus 6, so that's 3. And so let's actually find the slope between those. So we're doing 3 minus 0 over 3 minus 0. You also could put that function in your calculator and look at the table, right? And so that slope is 3 over 3, which is 1. So now it asks me to put these in order. So I've got 1 and 2. Those are very easy to order. Think about where 7/3 is. So 3 goes into 7 twice with a little left over, right? With 1/3 left over. So in order, these would go G of X, F of X, and then H of X. So smallest, medium, biggest. Okay, now here's a place where I've seen some struggling, and that's in interpreting what an average rate of change is. So a couple things when you do this. Number one, you need to talk about the fact that it's the average. Okay, it has to happen. It's not the slope, right? It's the average change. You need to talk about that it's over an interval. So for the last one, we'd say that was the average change from 0 to 3. And you need to include units. It's super, super important here, okay? You need average, you need the interval, you need some units. So let's look at this one. The height of a tree is given by this function h. H is measured in meters, t is measured in years. And it says, find the average rate of change between 3 and 5. Interpret your answer in context. In context means you better be talking about this tree, okay? So it says between 3 and 5. So let's actually calculate what that average rate of change would be. So calculating it would be 6 minus 2, that's my change in y, over 5 minus 3, that's my change in x. And that's going to give me 4 over 2, which is 2. Now that's all well and good. That's your average rate of change, but let's interpret this. So what that means, let's think about our units of this. Change in y is meters. And this is really over 1, and that is in years. So that's my units of y over my units of x. So this is 2 meters every 1 year, right? 2 meters per year. So here's what this means, okay? So on average, between years 3 and 5, the tree's height changes by 2 meters per year. So notice I said on average, I gave the interval of time, and I'm talking about the units, meters per year, right? Let's do one more of those. I know you guys know how to find slope. It's just that idea of being able to interpret it that's hard for some people. Okay, and again, send questions if you have them. That's why I'm here. Let's look at this one. A table indicates the number of cases of West Nile virus over a period of 4 months. What is the average rate of change in months in cases per month between 2 and 4? So there's where I am looking. So let's calculate it first. So change in y, so 16 minus 34, over change in x, 4 minus 2. Make sure you're consistent. If you start with 16, start with 4. And so that's going to be 2 in my denominator and negative 18 in my numerator. And that's going to be negative 9. Now, this is important. This is negative. So what that shows me is a decrease, right? That shows me a decrease. So, Hannah just asked, do the interpretations have to be in complete sentences? They don't, as long as they include all that information, right? So if you said that, like, 2 meters per year is the average change in height from 3 to 5. If you said it in some way where you included all of that, then you'll be fine. Complete sentences are normally the easiest way to do it. Okay, for this one, we had negative 9, right? So let's think about what that means. The units of y are number of cases. So this is number of cases. The units of x were months, so per month. And if it's negative, that means it's decreasing, right? So here's what this means. This means, on average, from months 2 to 4, right, there was a decrease, or the number of cases decreased, or you could say changed, by 9 cases per month. And notice I'm not saying negative 9 because I'm already saying there's a decrease, right? That would be a double negative. So you could either say it changed by negative 9 or you could say it decreased by 9. Okay, if you have more questions on that, let me know. We can do more at the end, whatever. All right, linear regression. This is I'm going to go through right now because I can't project my calculator up to you from my laptop at home. But I will sort of breeze through these. I will link a video in the description bar down below this that says how to do this. So if you need that, go look for it there. But you're going to go to Stat and then Edit, and this is right from your notes. Put in your list, L1 and L2. That'll be your X and Y. Then Y values, we talked about that. Then go back to Stat and then hit Right to Calc. And you're going to go to 4, which is linear regression. Go down to Calculate. And that'll be your regression equation, right? And so remember that this A value goes where A is and the B value goes where B is. So that's your slope and your y-intercept. Now, let's look at just solving with one of these. I'm going to assume that you can put that in your calculator. If you need help with that, come see me tomorrow. I'll be before school, after school, lunch, study hall, whenever. All right, so looking at this, a convenience store manager noticed that the sale of soft drinks are higher on hotter days. So he assembles the data in this table. So we've got temperature and the number of cans sold. So this is the regression equation that we come up with. And we want to predict the sales if the temperature is 95. So notice here that your input is temperature, right? So if you're trying to do this value, plug that in and you'd get out your Y value. Generally, you guys were very strong at that, but I just want to make sure we hit on it. Okay, inverses. This is one of our actual Algebra 2 topics, not just something that was review. So with inverses, remember the big idea is inverses switch X and Y, right? They switch your domain and range. They switch your input and your output. That's all inverses do. That's what you really need to know. So let's look at these. So algebraically find the inverse. So all I'm going to do that is switch X and Y. So remember that H of X is just another way to say Y, right? So the first thing I normally do is I rewrite this with Y. So Y equals the cubed root of X minus 3. Now, to find the inverse, let's switch X and Y. And then let's solve for Y, right? So I'm going to add 3 to both sides. And then I have a cube root, and so to undo a cubed root, I'm going to need to cube both sides. When I do that to the left side, I need to put it in parentheses. And it's not a bad idea to do that to the right side too. So this is going to be X plus quantity cubed equals Y. Now, the only thing to remember here is because we started with H of X, we should be ending with H inverse of X. And that would be my solution. I'm not actually cubing that out because to cube a binomial would mean you need to do x plus 3, x plus 3, x plus 3, right? And that's a lot of work that unless they tell us to do, we're not going to. All right, let's try letter D. We're not going to do all of these, but if you need more help, come see me. So again, we're going to switch x and y. So I'm going to make this a y to start with. Switch x and y. So x equals 7y plus 18 all over 2. And then I need to solve for y. So the big thing that I notice here is this division by 2. It's kind of in the way, right? So I'm going to start by multiplying both sides by 2. And that's going to make this cancel over here. That will give me 2x equals 7y plus 18. You also here could have put this over 1 and cross multiplied. Now I'm going to subtract 18 because I'm trying to get y alone. And then divide by 7. So y equals 2x minus 18 all over 7. Now remember here that we started with f. So I should end with f inverse of x is 2x minus 18 over 7. All right, the other thing we talked about with inverses was if we graphed the inverse, would it still be a function, right? We call that a one-to-one function. I'm not super worried about your vocab, but what I would say is you should be able to tell me, are there inverses functions? And there's two ways we can do this. So remember to graph an inverse, you can pick points and switch your x and y. So like this is 0, negative 2, so I could graph it at negative 2, 0. This is 3, 0, so I could go to 0, 3. This is negative 3, negative 4, so I could go to negative 4, negative 3. And that would give me a pretty good indication of what that will look like. Now, easier to draw it on paper than an iPad. That was okay. That red graph a function. It is. It's linear, right? So the other way we can test this is by doing a horizontal line test on our original. Because remember we said when we flip it over y equals x, which is this line, it should still pass a vertical line test. So as long as this black one passes a horizontal line test, then the red one will pass a vertical line test. Same thing with this one, and you could actually flip these points, but think, if this won't pass a horizontal line test, then when I flip it, that won't pass a vertical line test, right? So that would be a no. Okay, even and odd, symmetry, right? Another actual Algebra 2 topic. So even and odd, the things I want you to remember are this. So even, I want you to think equal, okay? Even should make you think that it's equal. So it's equal over the y-axis, right? And it's also equal in the points. So like if you plug in negative 2, you get out 1. If you plug in positive 2, you get out 1 because they come out equal, right? So even, think equal. For odd, I want you to think the opposite. So odd's going to look like it got turned upside down, like it got rotated. And for the points, if you plug in negative 2 and get 1, when you plug in positive 2, you're going to get negative 1, right? It's going to be the opposite point. So let's take a look at these. So even, the other thing is it's symmetric over the y-axis. Odd, it's symmetric when you spin it upside down. So for letter A, I look at that. That is definitely not symmetric over the y-axis, okay? The other thing is if I spun that upside down, if I actually took it and spun it 180 degrees, what I would wind up with is something like that. And notice this one has a y-intercept at negative 3. That one has a y-intercept at positive 3. So this is neither. It's not opposite and it's not equal. So that is neither. All right, B, that's symmetric over the y-axis. Notice that these are equal on either side. And so that's equal. This is even. And if it says explain, explain. I'm not explaining because I'm saying it out loud to you. All right, and then what would an odd look like? So let's look at D. Notice that if I took this, first of all, it's definitely not symmetric over the y-axis. But if I took this and I rotated it 180 degrees, which is a little hard here, it looks exactly the same, right? It maps onto itself. And so this is odd because it's symmetric about the origin. It's symmetric under that rotation. The other way you can check is you can say, okay, 2, 2, negative 2, negative 2, right? They flip. It's the opposite. All right, now proving this algebraically, and we did pretty well on this on the quiz, but let's make sure we got it. So proving it algebraically, we are to take the function and plug in negative x. And remember, equal will be even, opposite will be odd. So here, making sure that I'm using parentheses, I'm doing negative x cubed minus 6 times negative x. Oh. A negative cubed will be negative, and then negative 6 times negative x will be positive. So now let's look. Is it equal? Well, this is positive and that's not, so it's not equal. But that's opposite. Is this also opposite? So negative, positive. So notice that each term is exactly opposite, right? That means this is odd. Okay, let's look at this one. So here, if I do r of negative x, I'm going to do negative x squared plus 6. Notice the 6 doesn't have an x with it, so you don't need to put in a negative anywhere. So this is going to be a negative squared, which will be positive, plus 6. Notice that these are equal, right? And equal tells you that it's even. That would be symmetric over the y-axis. And then let's try c. So if I do h of negative x, this is going to be negative x squared, which will come out to be a positive, plus 2 times negative x, which will be minus 2x, plus 1, which won't change. And look at what we've got here. This is equal. This is opposite. I can already tell you this will be neither because you can't have some of each. And that's equal. So this one would be neither because some changed and some didn't. Okay. Now, I can tell you guys, let's see, we've got a couple things left, that from your quiz, this is a topic I would say we should look at. There's a reason that I photocopied the key to your quiz and I gave it to you guys because I wanted to make sure that you got practice with this. So here's the things we need to look at. So first of all, this is f of x. First it says what are the y and x intercepts. Remember, intercepts are where it hits that axis. So the y-intercept here is right there, that, right, just the y value. The x-intercepts are where it hits the x-axis. I see 2 of them. So that's 1, 2, 3, 4. And this is negative 1, 2, 3, 4, 5, 6, negative 6, right? Just the x values. Now, domain and range, this is where we started getting into some trouble on the quiz. So again, we're going left to right. So here, this starts at negative 8, and it's a closed circle on there, so I'm going to include that. It ends here at 6, so it's a closed circle. I'm going to include that. From bottom to top, the lowest that I see it hit, and I'm going to erase so we can see a little bit easier. The lowest that I see it hit is right there, and that's negative 1, 2, 3, 4. So that range is going to start at negative 4. And the highest I see it hit is up here, which is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, relative maximums. I know a lot of you guys gave me the maximum value, which is great. On your quiz and on the test, what you're going to see me ask you for is the coordinate of the relative maximums. The other thing to remember is relative maximums have to be a term, right? They have to be a maximum relative to what's around them. Remember when we talked about like Billy Fusillo is relatively famous compared to Beyonce, but like he's famous compared to what's around him, right? So an endpoint, we don't know what's around it. All right, so let's look at some maximums. So here, anytime you see kind of the top of a hill, I see one here and I see one there. And again, I'm going to ask you right now for the coordinates of it. So this is 1, 2, 3, 4, negative 4, 2, 3, 4, 5, 6, 6. So that coordinate would be negative 4, 6. And this won't let me zoom out. There we go. Okay. And then for this one, we're at 2. 1, 2, 3, 4, 5, 6, 7, 8. And I did not put a U between those because of the I got excited. I started talking too fast. Those are not intervals, right? The U is the thing that connects intervals together. This is not an interval, so just list them. Relative minimums, again, I'm looking for terms. This right here over in this corner is not a relative minimum. It's not a term, right? We don't know what happens on the other side of that end. So the only relative minimums that I see are right there and right there. So at -1, 1, and again, I will ask you for the coordinate and I will say that. And then at 1, 2, 3, 4, 5, -2. And again, there's no U because a U is what links intervals. All right, let's talk about the elephant in the room, which is that a lot of us get confused on increasing versus positive and decreasing versus negative. So where is the function decreasing? Think about it. If something's decreasing, it literally means going down, right? So where is this function decreasing? Anywhere it's going downhill. So it's going down here and it's going down there. And that's it. Not where it's below the x-axis, right? Just going down, having a negative slope. So let's look at these. We're going to give a range of x values. So this is where it ends. This is where it starts. So -1, 2, 3, 4. So from -4 to -1, the function is decreasing. So -4 to -1, right? And then here, I'm starting at 2 to right there. So 2, 3, 4, 5. From 2 to 5. And since that's an interval, I'm adding a U in there. I'm joining those together. Now, on the interval from -1 to 2, is f increasing or decreasing? Let's look at that interval. So the interval from -1 to 2 is that those are x values. So -1 is here, 2 is there. I see a positive slope. That means it is increasing. So increasing because it's going uphill, right? And you are not going to write INC and then not explain on the test, but I'm explaining it verbally to you. All right, state the interval over which f is greater than 0. That's saying where is it positive. In other words, it's saying where is it above the x-axis. Anywhere here. So I know that my 0's x in at 4, right? And so that's going to be the interval. It's going to be from -6 to 4. Excuse me. Now, notice I use parentheses because at -6, the function is 0. It's not positive. At 4, the function is 0. It's not positive. So I'm keeping parentheses there. All right, and then the last thing it says is graph them. Where do they equal each other? So 2x minus 1, your y-intercept would be -2 or -1, and your slope would be 2. And where do they equal each other? Where is going to be an x value? They equal each other at 1, 2, 3, at x equals 3. And again, that's like old Algebra 1 stuff. Okay, we have like 2 topics left. So we're going to do a system, and then we'll talk about sequences really quick, and then we will be done. Actually, you know what? You guys are pretty rock stars at systems. So if you want to review a system, I'll put a link to one of my systems reviews from last year in the bar down below. So just click that. But right now we're pretty good and we're starting to lose people. I think we're starting to lose some steam. So I'm going to skip that for now. Okay, last thing is sequences and series besides your prereq skills. So sequences and series, the only thing that I'm going to give you on the test is this. AN equals A1 plus N minus 1 times D. That is the formula for an arithmetic sequence, okay? So that's important to know. So we will come back to that as needed. So these first ones say determine if the sequence is arithmetic and determine the common difference. So write the first 5 terms. If it's arithmetic, find the common difference. So let's look at the way these are written. So for this first one, they say AN and then 4n minus 3. Notice, it's not saying that it's depending on the term before it. So this is an explicit formula. Okay, if I want A1, I will plug in 1. So A1 here will just be 4 times 1 minus 3. And that is just 1. A2 will be 4 times 2 minus 3. which will be 5, and so on. And I can tell you guys, if you keep doing that, you'll get 1, 5, 9, 13, 17. And here's how I knew that, okay? This had a slope of 4, right? And so that's going to be my common difference. So this is arithmetic, and the common difference is 4. Now, you could just plug in numbers and you'd get that too. All right, we're going to look at a different one. B is written very much the same way. C looks different. C says, here's your first term, and here's your pattern. This is recursive. Remember that recurring thing? So my first term is 9. My second term is going to be the first term minus 13. So the first term minus 13, 9 minus 13 would be negative 4, right? And then my third term will be the second term minus 13, which would be negative 17. And we could keep going that way, right? We get all 5 terms. And then we could look at these and say, well, is this arithmetic? Now notice, we have a pattern, and the pattern is subtract 13. So I would say, yes, this is arithmetic, and the common difference is negative 13. Okay, we're going to do one of these. So write an explicit and recursive formula for these. So let's start with this. So let's start with recursive, because that's what we started with in class. So recursive should be the recurring pattern. The recurring pattern here from 7 to negative 8, well, that's actually minus 15. So the pattern is AN equals the term before it minus 15. That's my recurring pattern. But I need to know where to start. So A1 should equal 7. And remember, we talked about this in class. You didn't win my $5 bill because you didn't ask both questions, right? Now, explicit, this is just about using that formula that I give you, right? So AN equals A1 plus n minus 1 times your common difference. And you could rewrite this, 7 plus, distribute this out, negative 15n plus 15, which would be negative 15n plus 23. Yeah. Okay, so explicit versus recursive. All right, let's look at one of these. Find the indicated terms. So I know A1 and I know D. I want A12. That is asking me to use the explicit formula. To find A12, I'm going to do A1 plus n minus 1, n here is 12, because that's the one I want, times the difference, which is 2. So that's going to be 2/5 plus 11 times 2, which is 22, and that's 22 and 2/5. You could also put that in your calculator. Okay, and then an applied problem. So an arithmetic sequence has a first term of 10 and a sixth term of 40. What is the 20th term? So to do that, I need to write a formula. So A20 is going to be A1 plus 20 minus 1 times the common difference, right? And we know A1 is 10. So I just need to know the common difference. And what I want you guys to remember is common difference is the same as the slope, right? These are linear in their behavior. So I know that the first term is 10. I know that the sixth term is 40. So to actually figure this out, I'm going to do 40 minus 10 over 6 minus 1, find my rate of change there, right? Which is 30 over 5, which is 6. My common difference is 6. So plugging that in, I'm going to have 10 plus 19 times 6, and that'll give you your final answer. Okay. And then the only other thing, guys, because we haven't asked any more questions, is your background skills. These were great on your prereq skills. If you need help on these, come see me. But factoring, simplifying square roots, adding, subtracting, and multiplying polynomials. And that's it. If you can do those things, you are ready for this test. So I just blabbed at you for 50 straight minutes. So I'm going to hang out for a minute or two. I will take any questions, but I will be before school tomorrow, after school, and you can always come see me lunch or whenever. Just text me and I'll let you know if I'm free. So I'm going to hang out. Thank you for watching. And yeah, send me questions for a minute. Anybody? Be the person that asks. People are waiting to see if you're going to ask. I'm taking a picture to send to Mrs. Bell of us live streaming. All right, this is it. Last call. All right, guys. Well, thank you for watching. We had a good crew on here. If you're watching this later, thank you for studying. Let me know if you have other questions. You guys are going to do great. Just make sure you're prepared. Ask all the questions you can. And the nice thing is once Tuesday's over, you get an extra day without math this week. All right. I will see you guys later. Have a wonderful